your 5.4 lesson goes over matrices. What a matrix is another way of writing a systems of equations. So you're going to have, or what we're going to start by looking at today with your matrix or with your matrices is your dimensions. When you look at matrices, you have rows and you have columns. Your rows are the numbers that go side by side. Your columns are the ones that go up and down. So you will have rows and columns. Your dimensions of a matrix go row by column. So it's written as the number of rows by, or x with your times, your number of columns. Same thing that this says, row by column. If we look at an example, it tells us to determine the dimension of each matrix. For example, A, you just have that 2. So you have 1 row by 1 column. So this is a 1 by 1. And you can put that in parentheses. For example, B, you have the matrix with the column 1, -3, 0, 1/2. You have 1 column here, 1 row by 1, 2, 3, 4 columns. So this is a 1 by 4. For example, C, you have the matrix 0, 0, 0, 0. So this one has 2 rows by 1, 2 columns. So this is a 2 by 2. For example, D, you have the matrix 5, 0, 2, -2, -7, 4. So this one is giving you 1, 2, 3 rows by 1, 2 columns. So that is a 3 by 2. For example, E, you have the matrix -2, 0, 1. This one has 1, 2, 3 rows by 1 column. So that's just a 3 by 1. The next part of your notes is going to be looking at the different types of matrices. You have something called an augmented matrix that includes your answers for systems of equations. Then you have something called a coefficient matrix, which is just the coefficient parts of your matrix, of your system of equation. If we look at something like x minus 4y plus 3z is equal to 5, negative x minus 3y minus z is equal to -3, and 2x minus 4z is equal to 6, that is giving us a system of equations. Now, you have an empty spot on the y of your last equation. We can add in a 0y to represent that y that's missing, and that takes the place of that coefficient and that part within your matrix. If we look at an augmented matrix representing this system of equations, you're going to include your answers. So your first equation, that x minus 4y plus 3z is equal to 5, gives you the 1, -4, 3 with the answer of 5. With this, you'll see that your coefficients are there in each of your rows for each of your columns for x, y, and z. And then your answers are to the right of those 3 little dots for each equation. Those 3 little dots designate that is the answer for that equation. You can either use those 3 dots or you can draw a straight line to represent them. Okay, so anything to that right of that straight line would be your answers. For that middle equation, negative x minus 3y minus z is equal to -3. You have a -1, a -3, this should be a negative, and a negative z, so that's a -1 for your coefficients, and your answer is -3. So that should give you the -1, -3, -1, -3 row in your augmented matrix. Again, you're going to have to put that negative in on that middle 3 of the augmented matrix. For your last equation, you have the 2x plus 0y minus 4z is equal to 6. You're going to pull that 2 from the x, and then it'll go down in your first column all the way at the bottom. That 0, because there isn't a y, goes in for that y place underneath the second column. The negative 4 that's in front of that z goes down in that third column, and then your answer is 6, so that goes to the right of those 3 dots or that line that you have there. So that would be your augmented matrix. Your coefficient matrix does not include your answers, and it's just the coefficients from all of your numbers or all of your terms. So that's giving you the 1, negative 4, 3. The negative 1, this should be negative 3, negative 1. And 2, 0, negative 4. If we look at some examples, we're going to write the system of equations given the augmented matrix. So, for example A, we have 3, 0, 7 with an answer of negative 5, then 6, negative 4, 11 with an answer of 0, and negative 2, 1, negative 3 with the answer of 5. So this will be your x column that goes first, then your y column, then z. Anything to the right of those 3 dots are your answers. So we're first going to have the 3x plus 0y plus 7z is equal to negative 5. Then we have 6x minus 4y plus 11z is equal to 0. And lastly, negative 2x plus y minus 3z is equal to 15. Now, you do not need the 0y in there. You could just write it as 3x plus 7z is equal to negative 5. That's totally okay. But if you want to keep that place value in there, you need to make sure that it's that 0y. In example B, we have the matrix negative 6, 1, 3, 2 with the answer of 27, 9, 3, 8, 0 with the answer of 17, 0, negative 5, 7, 13 with the answer of 31, and 4, 8, 16, 24 with the answer of 53. Now we have 4 variable terms here. So instead of using x, y, and z, I'm going to use a, b, c, and d. So that way I have 3 or 4 consistent letters that I'm working with. So this first equation is going to give us 6a minus b plus 3c plus 2d is equal to 27. Then I have 9a, 3b, or plus 3b, plus 8c, plus 0d is equal to 17. Then we have 0a minus 5b plus 7c plus 13d is equal to 31. And 4a plus 8b plus 16c plus 24d is equal to 53. So just like we said with the one that we did before this, if you want to put in that 0d underneath the 2d in the second equation, you could. Same thing with the 0a in the third equation, you could. Do you need to? No, because these equations are equivalent without them. For your last examples, it tells you to write the augmented matrix for the system of linear equations. And it asks you for the dimensions of the augmented matrix. We're not going to do that. We're just going to write the augmented matrix for both of these. For example A, you are given x plus 3y is equal to 9, negative y plus 4z is equal to negative 2, and x minus 5z is equal to 0. For your first equation, you have coefficients of 0, 3, and 1, or sorry, not 0, 1, 1, 3, and 0 for that z. Your answer for this one is the 9, So we'll put that to the right. For your middle equation, you do not have an x, so we're going to put in a 0 for the x. A negative y would be negative 1. And the 4z is 4. Do your 3 dots and your answer of negative 2. Lastly, we have the x and the negative 5z. So the 1 goes down for x. We do not have a y, so we'll put in a 0 for your y. And that negative 5 will go in for that z place. Your answer goes in after your 3 dots of 0. So that would be your augmented matrix. If you were to do the coefficient matrix, you would just have the 1, 3, 0, 0, negative 1, 4, and 1, 0, negative 5. Your augmented matrix would be a 3 by 4. Your coefficient matrix would be a 3 by 3. For example B, you're given the system 2x minus 3z is equal to 14. Negative x plus 4z minus 7, plus 4y minus 7z is equal to 33. And 4x minus 5y plus 9z is equal to 2. From your first equation, you have a 2 in your x. You don't have a y, so that's going to be 0. And you have a negative 3 for z. So those will make up your first row of your first, like your 1, 2, and 3 column. Your answer on this one is that 14. So we'll put that to the right. From here, that middle equation, you have a negative x, so that's negative 1, a 4y, so that's 4, and a negative 7z, so that's the negative 7. Your answer is 33, so that'll go to the right of those 3 little dots. For your last equation, you have a 4x, so that 4 goes down first, then a negative 5y, so you'll write down that negative 5, and then the 9z, so that 9 goes down. Your answer for this one is just 2. You put your brackets around it, and then you're done. And again, that's your augmented. For your coefficient matrix, you would have just the 2, 0, negative 3, negative 1, 4, negative 7, and 4, negative 5, 9. Your augmented matrix would have the dimensions of 3 by 4, and your coefficient matrix would have the dimensions of 3 by 3.